Hey, what's up guys? Back again with another video in the C++ series. This time I'm going to teach you how to use pointers. Alright, so I don't know about you, but when I first heard about pointers I was a little discouraged because it looked pretty hard. It looked like a hard concept when I tried to first learn it. But and other people have said that also, but it's a pretty simple concept actually. Once you learn the basics of it, you can build upon those basics and then have a good understanding of it. So that's what we're going to do this episode. I'm going to try to teach you the basics of pointers, how they work in as much detail as possible, and then we can build on from there. So also I'm going to be using this new thing here so I can draw on the screen, and it's going to allow me to represent and show you concepts in a way that I can't show you by typing and coding. So I need to explain pointers, so I'm going to try using this for the first time by drawing and showing you a few things before we actually begin coding. So we will begin coding later in this episode, but first I'm going to do a little introduction so you know before we code what's happening. So yeah, let's get started here. So the first thing you may ask when you hear about pointers obviously is, what is a pointer? And a pointer, you can say a pointer, by the way I have very bad handwriting, so sorry about that. So a pointer is a variable that stores a memory address. Okay? And you probably don't know what memory addresses are. If you do, that's good, but if you might not, if you have only watched this series, so I'm going to explain that to you. So I'm sure, I hope by now you know what memory is and how RAM works. So RAM stands for random access memory, and that's the same thing as saying memory, of course. And all computers have memory. That's how computers store information temporarily. Like whenever you start up a program, it uses a bit of your memory, your computer's memory, so that it can store some information. And then when the program ends, it frees up that space for other programs, basically. And then anything that cannot be stored in the memory, or anything that needs to be in the memory but forever, basically, whenever the computer's even off, would be stored on your storage, your disk drive or your SSD, basically, I guess you could say. So let's talk about a little bit about how memory works. So we know there's a bunch of different data types, of course. So we have an integer, and that's about 4 bytes of space, size, I guess you could say. And then you have double. Those are the two most common that I use, is integer and double, and that one's 8 bytes. And of course, the size actually does depend upon your machine and your compiler and stuff, but generally speaking, for C++, it's usually 4 bytes for an integer, 8 bytes for a double, and so on. So these are just general values, so they may differ. But we also have a long, which is 8 bytes. And then we have a short, which is 2 bytes. I think. Yeah, 2 bytes. And then we have a char, or a car, however you want to pronounce it, and that's 1 byte. And if you don't know what a byte is equal to, oops, how do I go back? I'm still trying to figure this out. So let's try erasing this. There we go. Go back here. A byte is equal to 8 bits. Alright? So now that we know the different sizes that every different data type, or not every different data type, but a few of these data types will take up, we can then explore how they are used in our memory, how they're represented. So just pretend that this little chunk here that I'm about to create is a piece of your computer's memory, okay? And we can section off the memory into imaginary little squares here, and each of these squares will be equal to 1 byte, okay? And so we know, so pretend, and of course your memory is very big in terms of how many bytes it has, so we'll put a ... around this because this is just a chunk of it, just a random section that we have created. So let's say in our program that we want to create an integer, and we'll call this integer Bob, and then Bob is equal to 25, alright? So whenever we create Bob, what it's going to do is find a spot inside of our computer's memory. It doesn't really matter where the spot is exactly, but it's going to find a spot there and then choose a spot to put it. So since a integer is 4 bytes, it's going to choose 4 bytes in your memory, alright? So that's how that's going to work. It's going to allocate 4 bytes of space, and this 4 bytes of space is going to represent Bob, or the value of 25, alright? And then let's say we want to create another value, maybe a short, right? So short let's think here, short bcoff is equal to 1, because he's really short. So let's say our computer decides to put it right here. So that would be 2 bytes of space, right? So 1 would be what that corresponds to. So 25 is the value stored in these 4 bytes, and then 1 is the value stored in these 2 bytes here. Now, think about it this way. Our memory is so freaking huge, it has so many different bytes that each byte needs an address, or our memory, certain parts of our memory need an address, because you have to be able to locate stuff, right? How is your computer supposed to know where to find this information if it's supposed to go through a giant chunk of memory? It can't just go through the memory and say, oh, 25, I found it. It needs to know where to find it from in our memory, right? So that's why we have addresses. So each chunk here, each byte here has its own address that the computer or the compiler, however you want to say it, is able to find information from, retrieve the data from. So just starting from the beginning here, we're going to say this address is 001, this one is 002, 003, and so on. 4, 5, 6, 7, 8, 9, and then 10. And of course, in an actual situation where we're working with real memory, this it wouldn't be labeled like 001, 002. It'd be like a weird looking hexadecimal value, like ampersand. I don't know how to draw an ampersand, H986C or something crazy looking like that. It wouldn't be these simple values, but just for demonstration's sake, we're going to use those simple values. So now that we know that our memory has different addresses assigned to it for each part of it, we can then assume that our compiler, or basically our program, is storing these addresses so that it can access these values at any time, right? Because Bob is how the programmer is able to access the value of 25. But let's say that we go down here and do Bob is equal to 27. Let's say we reassign it. How is the compiler supposed to know where to find the value of 25 and then change it? It needs to somehow find Bob by going to the address of 003 in this case, and then change it to 27. Change the value of whatever is at that address. All right? And keep in mind, even though Bob starts at address 003, it's 4 bytes, so it's going to actually be 003 through 007, right? Because the 4 bytes, right? So just don't forget that. It's not too important, but it's helpful to know something like that. And same thing for short, and same thing for any data type that we have here. That's just how values are stored. That's how they're retrieved. It's all centralized on memory and memory locations. So memory locations are just how you find it, basically, kind of like an address in real life. How do you find someone's house in a neighborhood? You have their address. It's kind of common sense. Now let's talk about a new type of variable. So currently we have all these data types here and a few other primitive data types, but now I'm going to teach you about the pointer. So the pointer is usually 4 bytes, generally speaking, but it can actually vary, just like the other ones can. But generally speaking, it's 4 bytes. Sometimes it could be 8 bytes and stuff like that. But yeah, so a pointer is 4 bytes, and again, if you don't remember, what does a pointer do? If we go back up here, a pointer is a variable that stores a memory address. So these variables that we have down here, these data types, store numbers, floating point numbers, characters, stuff like that. But a pointer stores a memory address, okay? So let's think about that. So let's say that we want to store the memory address of a random value. So let's say, okay, first let's start off simple. So let's create a random value. So double random is equal to 28. So what is going to happen here? So that means that our compiler, or whatever is running our program, is going to allocate 8 bytes of space inside of our computer's memory to store the value of 28. So now let's say, let's visualize this. So let's say we have a chunk of memory here with the value of 28, and this is 8 bytes, of course. And let's say that this address happens to be 8679, something crazy like that. How about 90? Alright, so this is the big address that the value of 28 is stored at in our memory. We can actually create a pointer, which is another variable that stores this memory address value, meaning that we can at any time access the value at that memory address and then even change it if we want to. We can even change the value of the memory address to be any adjacent variable next to this memory address. We can do a number of different things, which is very interesting. So let's try making our first pointer here. So if we're going to create a pointer, what we want to do is provide the data type of what the pointer is associated with. So since we're storing the value, oh wait, it's a double, right? So this would be 28.0, wouldn't it? So that would make more sense, obviously. So 28.0, sorry about that. So since we are storing the memory, we want to store the memory address of a double, we need to provide the data type of the memory address, of what's stored at the memory address, so that would be a double, okay? Now we need to give our pointer a name. We're just going to call it PTR, which stands for double. And then now, on the right side, we need to provide the memory address of whatever we're trying to store, right? Because again, a pointer stores a memory address, so we need to actually store a memory address, obviously. So you can't actually just go into here and do wait, I can't, there we go, 86790. That doesn't work. It's not an integer. You can't just type it in like that. What you need to do is actually, there's a special operator you can use to get the memory address of any variable in any object. So let me just try and erase this if it'll let me. There we go. So how do we get the memory address of any variable in any object? We would use the ampersand. I don't know how to draw an ampersand again, but pretend that's an ampersand, and then now we provide the name of the variable that we want to get the memory address of. So ampersand random will give you the memory address of random, just like that, and put a semicolon on the end. But we're not done. We are storing the memory address of random here inside of a double named PTR, but we don't want to make a double, we want to make a pointer to a double, right? So we would put a star, an asterisk, in front of this, and we'll explore the different ways we can create pointers in detail once we're done with this short introduction. When we start coding, we'll go into detail on how we can create pointers. But generally speaking, this is how you create a pointer, okay? You gotta give it a data type, you gotta give the star, the asterisk, you gotta give it a name just like any other variable, and then you gotta get the memory address of what you want to be storing, okay? So now we have created a pointer which points to the memory address of a double called random with the value of 28.0. Pretty cool, right? So what would happen as soon as we, so basically what happens when the compiler gets to this line here, right? What is going to happen? What it's going to do is make this right here. It's going to allocate the space in the memory, assign it the value of 28.0, and then of course that's 8 bytes of size, and it has an address. But once it gets to this line here, right here, what is it going to do? It's going to assign another chunk of memory, because like I said, a pointer is just like a regular variable. At the end of the day, it's a regular variable, but instead of storing a double or integer or something like that, it's going to store a memory address. So the value of this variable in the chunk of memory would be 86790, if that's the memory address that we're storing. All right. So of course, like I said, most pointers are 4 bytes, generally speaking. So this will be 4 bytes in size. So up here we could represent that as 4 squares, just like that. But yeah, so 4 bytes. And then, like I said, again, a pointer is a regular variable, so it's actually going to have an address of its own. So let's give this a random address as well. We'll do 0941. So that's the address of our pointer variable that we just created. So we'll just section this off. At the end of the day, just remember that they are storing memory addresses. So that's why they have addresses of their own, and they have places in their memory, because it has to store the value of what they're storing somewhere, right? But let me explain one more thing real quick. So let's say in our memory, we have a chunk of memory here. Just pretend this is a chunk of memory again, like we had above. That's not the shape I wanted. That's fine, there we go. And now let's section this off. So we'll say that this chunk here is 4 bytes. And this 4 bytes will hold the value of 287. All right? And then this section here is 8 bytes. And this will hold the value of a long of 682005821, which is a really big number because it's a long, right? And let's say we have another chunk in our memory somewhere. Doesn't matter where, but it exists, right? Okay, that's a little too small. Let's try doing this. There we go. That's better. So now let's say this chunk of memory has a pointer inside of it, which is again just a regular variable that holds a memory address. And inside of this pointer, what we want to do, of course a pointer is 4 bytes, right? But we want to store the address of our long right here, right? So what would be stored inside of here if this pointer points to this long that we have here? The value that would be stored inside of here would be the address of this 8-byte chunk of memory, or the starting of that address. So let's say the start of this 8 bytes, the first byte would be 0015, right? Let's just pretend that's the value. So that means that inside of here we're going to store 0015, just like that, because this pointer here is storing the address of this lung that we have here. Okay, so we can say that this points to this, and that's actually where the name pointer comes from. A pointer, you can say that this pointer here points to the memory address of a long. That's what that would mean. That's why it's called a pointer. It's pointing to the memory address of a long variable. Okay, but let's say we have another chunk of memory here somewhere in our RAM, and this chunk of memory will have the value of whatever this memory address is here. So since this pointer is also a variable, it's going to have a memory address of its own, like I said. So let's say that this memory address is 0217. That means inside this one, if this is a pointer, let's store 0217, and this one will point to here. So what we're doing here is kind of crazy. We have a pointer that's pointing to another pointer, which is pointing to a long memory address, which is kind of crazy. Yeah, that's how that works. You can have pointers to variables. You can have pointers to 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 variables. You can have as many as you want, really. It's kind of crazy. You can even have arrays of pointers, which we'll see later. It's just a bunch of pointers, okay? But yeah, in essence, that's pretty much it. That's how pointers work. There's a lot of, it's pretty basic. At the end of the day, you just have to remember this really essential rule that a pointer is a variable that stores a memory address. And then now when we start coding in a second here, we'll see the different ways of working with memory addresses, how to get a memory address, just like we did here, and some actual practical coding will take place. So hopefully I explained all that well. This is my first time again using this drawing software and this drawing tablet that I bought. So let me know if you enjoyed it. I know my handwriting is probably pretty bad, but let me know if you enjoyed it, enjoyed the explanation, if it helps you learn, and let me know how I can improve on these episodes when I use this kind of stuff. Alright, so let's get started here. The first thing I want to do, of course, is set up the basic skeleton project. So let me just get rid of this stuff here. And the first thing we talked about a second ago was memory locations. So we need to figure out first, how can we access a memory location, because a pointer is a variable that stores a memory location. So how do we get memory locations in the first place? So I'll just make a title here, pointers in C++. And by the way, I'm experimenting with this new zoom in thing as well, so that you can see my screen better, because I have a very large screen, so I think zooming in will probably help you a bit. So let me know if you enjoy it. And so the first thing we're going to do is we need a basic variable just to test this on, obviously. So integer thing is equal to 1800. And what we want to do is get the memory location of this variable. And to get any memory location of a variable, of an object, which we'll learn about later, all you need to do is put a ampersand in front of the name. So let's do it like this. So first we'll do cout, and then now we need to get the memory location of it. So we'll say ampersand thing like this. I forgot to zoom in for you guys. There we go. So ampersand thing, and that should print out the memory location of thing. So all you got to do again is just put an ampersand in front of it, and that should retrieve the information. Return the memory location of that variable or object. So now let's run this and see how it looks. Alright, so we get this weird thing in the console, and that's why I told you earlier that a memory location doesn't look like what I had it on the screen. I was drawing it as 001, 002, but rather it looks something like this. It's a big hexadecimal looking number, so 00BDFC84, and so on. So that's what memory addresses actually look like when you print them out. So let's play around with this a bit if we can. So let's say that, oh, by the way, if I was going to run this again without even changing the code, we would get a different memory address every single time, because the way this works is memory is very large, so it's just going to choose a random location in our memory to allocate the space for this variable here, especially since our memory is changing all the time. So maybe the memory that was this was in before is now held by something else, another program or something like that. So it's going to be held in a different spot, or any situation like that. But the point is that it's different every single time. So this time we get 004FF DB8. So yeah, so now let's play around with this some more. So let's make some more variables here. So we'll make a double thing2 is equal to 25.6. And let's say we want to print out the memory location of a double. So then we would just do ampersand thing2. So just put ampersand in front of the variable name, which is good. And now let's run this, and we should get 2 memory locations into the console now, and we do. So we get 00AFF920, and then we also get 00AFF910, which is interesting. But yeah, there we go. That's how that works pretty much. It's a pretty simple concept. All you gotta do is put the ampersand in front of it. So let's do something real quick. Let's get rid of this one for now, and then let's just print out all of the information that we could possibly print out on the thing in a integer here, right? Or not all the information, but just some basic stuff. So first we'll say the value of thing is, and then thing. Simple enough, right? And then now we can also do cout the size of thing is, and as you know, it's going to be 4 bytes for most people. So, oh yeah, to do size, it would be size of, and then inside the parentheses you would put the variable that or object that you want to get the size of. So this would be 4 bytes for an integer, and then cout for the last thing we'll do the memory location. So we'll say the memory location of thing is, and then we'll print out ampersand thing, just like that. And that should give us a good amount of information to work with here. And boom, so now we get the value of thing is 1800, the size of thing is 4, so 4 bytes, and then the memory location of thing is 00BAF74C. Pretty interesting. So this is good. We know how to access memory locations of pretty much anything now. But the thing is, what if we had just a variable like this, or just a number, 1800, but we can only print it out or work with it one time? Wouldn't it be useful to store it like we're doing here inside of a variable that we can access it at any time? That would be very useful. So storage is very useful. So what if we could store the memory location instead of just having to do ampersand thing every time that we want to access it? Why not just have a set location or a set way to access this memory location of this thing variable? So the way that we can store a memory location, as you know by now, is a pointer. So let's look at the different ways we can create pointers. So to create a pointer, all you need to do is provide the data type of the of what is stored at that memory location. So in this case, we're storing the memory location of thing, but we know that an integer is stored at the memory location. So we need to provide the data type, so integer, and then now we need to give it a name just like any other variable, right? So we can keep track of how to access it. So we're going to call this pointer to integer, and then we're going to do is equal to, actually no, we'll make a double just for more variation here. So we'll say double thing2 is equal to let's say 24.0, and then we'll change this to pointer to double, and then now we need to assign it. So we just need to store the memory location, so we'll do ampersand thing2 just like that, but we're not done. So it's already complaining, as you can see here. If we hover over this, it says cannot initialize a variable of type integer with a R value of type double or something like that. So this is basically automatically recognized as a memory address. So the way that we tell C++ that this is a pointer and that this is a regular variable that stores an integer is by putting the # before the name of the variable. And it can actually go right here. It can go in the middle if you want to with the space around it, or it can just go in front. Most people do this. I use this too. So this is how most people declare pointers. You just have to have the star here. I forgot what the actual name of it is. I know I said it earlier in the video, but I'm going to just call it a pound for now. So anyway, we still have an issue here. It says cannot initialize a variable of type integer with a R value of double. Oh, that's why. So double, just like that. I think that's why I was complaining. But anyway, so yeah, we created a pointer right here. And what does this pointer point to? It points to the memory location of a double. So that's how you would, that's why you would call it a pointer. And that's why you would give it the type of double. So it points to what? It points to the memory location of thing2, which happens to be a double, which is right here, not right there. I meant this one. And like I said, you can do that however you want to, like that if you want to, no problem. So now let's try printing it out just to see that it works, just to prove it. So let's say memory location of my double. And then we'll say pointer to double, and then inline. So now let's run this and see if it works. Let's see what we get in the console. So first we get the first 3 lines, which is from up here, but then we get memory location of my double is 006FFCA and then C, which is interesting. So that's, I mean, we can assume it works. Of course, we can't actually just read this and understand what it means, but it's different from this one, so we know that each of our variables are getting different memory locations, which makes sense since we know how memory locations work now. It's pretty random. So yeah, that's how you do that. You can print it out just like we would print out this one. It doesn't really matter. It's just a variable. And also, some people get confused whenever you're first learning about pointers. You may think that pointing out the variable would print out the value stored at that variable, which would happen to be 24.0. But remember, a pointer stores a memory location, so it would print the memory location itself, not the value stored at the memory location. All right. And of course, we can experiment with other things like booleans. Booleans are variables just like any other thing, so we can get memory locations from that. So we could say, is Cody cool? And I'm very cool, so I'm going to just put true. And let's see here. Let's store this in a double of its own. So bool. So we would say it's a pointer to a memory location of a boolean. And then we'll give it a name of ptr bool, so pointer to a boolean or however you want to say it. And then we need to give it a value, so we'll say the memory location of is Cody cool. And so now if we want to test this out, we can print it out. So cout memory location of my bool, and then say ptr bool, just like that. And we're not going to get true, we're going to get the memory location of is Cody cool. And yeah, we do. So we get 008FF92F, which is interesting. And yeah, so hopefully that concept is not too hard for you to understand, but that's just how you access a memory location, and this is how you store it with a pointer. So now that we know how to create a pointer, what if we want to get the value stored at that pointer location? So let's think about this. We know, well, let's make a new example here. So we're going to make let's think here. We'll make another integer because I like integers. We'll call this integer Bob, and Bob is going to be equal to 47. And now we're going to make a pointer to Bob, so we need to provide the data type and then denote it as a pointer with the pound, I guess I'll call it. And then we'll do, let's call it ptr Bob, and we'll say the memory location of Bob, okay? So also, by the way, I want to say that whenever you're declaring a memory location, I think I told you this before, I might not have, but you can't just type a memory. Let's say you happen to somehow know magically what the memory location will be, which is pretty much impossible. You can't just type it out, or even as a string, you can't just type it out or whatever, you know? You have to do like this. You just can't type it out, that's the only thing. So just don't forget that. It's a pretty simple concept, but don't do it. And so yeah, what I was going to say is, what if we want to get the value stored at this memory location here? So if we print it out before, like we just saw, if we print out ptr Bob, what are we going to get? We're going to get the memory location itself into the console, okay? So let me just print it one more time just to reiterate on that. So yeah, we get 012FFE08. So what if we want to get the integer? So we know it's an integer in our head. We can read this and we know it's an integer. So how do we get it? So we would get it by dereferencing it. That's what it's called. So dereferencing. And how do we dereference something? We use something called the indirection operator. And the indirection operator is actually pretty simple. All we got to do is, let's say we're going to print out the value stored at ptr Bob. Okay, so let's try that out. So we would do cout, and then to use the indirection operator, it's just literally another pound symbol, and then ptr Bob, and then inline. So what this will do is print out the value stored at ptr Bob, assuming there is a valid value there. If there is not a valid value, then just pray that the program does not break or something. I actually don't know what will happen, but you probably just get an error or something like that. I don't know. We'll see in the future. But let's see what happens when we print this out now, or run this and see what happens when it prints out. Alright, so we see down here we get 008FF6E0, and then we get 47, which is exactly right. That's exactly what we stored in Bob, but we're not printing out Bob. We're dereferencing ptr Bob by using the indirection operator. So now that you've heard me call this the indirection operator a few times, you may say, why didn't I call this one the indirection operator? That doesn't really make sense. Well, that's because it depends on the context of how you are using it. So if I put it in front of a pointer, that's what makes it a indirection operator. And same thing for if you're going to multiply something, 5 times 7, that wouldn't be the indirection operator. That would just be some simple multiplication. So that would be the multiplication operator. So it's kind of the same thing. It just depends on how you use it, the context of how you use it. So in this case, it's the indirection operator, and what that is, and what that does, it sorry if you heard my speaker, dereferences a pointer. That's all it does. And dereference means to convert it to the value at that memory location. Let's do a few more tests here. So we have some pointers up here. Let's try dereferencing those pointers to get the values at those locations, okay? So we'll do cout, and we'll do the first one is thing2. So let's try saying value at thing2 pointer, and then we'll say indirection operator thing2. Or you could just say, star thing2. It doesn't really matter what you say. Oh, right. That's okay. I see the problem here. So we're using thing2. Thing2 is a variable. I meant to target this one, double pointer to double. That's what I meant to do. So we'll change this to the proper name. So instead of thing2, it's pointer to double, and then the same thing over here, pointer to double, because you can't dereference a value. It's already a value. So now that should print out that value. So now let's do the bottom one, which is ptr boolean. So value at ptr bool pointer, and then we can dereference that. So actually we'll not dereference it, so you can just see the difference, just to reiterate on the concept basically. So if we print out this one on line 30, we should get 24, because that's the value stored at that location. But now let's try doing this one here, ptr bob, which we did not dereference, so what it should print out is the memory location, and that's exactly what it printed out right there. So now let's try dereferencing it. Instead of ptr bob being the memory location, since we dereference it, it should be, true, because that's what the value is, just like that. And then, yeah, we get 47. Wait, no, 47. Oh, not ptr bob, I meant ptr bool. That's why. So, oops. There we go, so we get 1. Okay, so 1 is of course standing for true in this case. But y'all get the point. But yeah, that's pretty much almost all I want to show you. I want to show you something else real quick actually. Earlier in this episode, when I was talking about memory locations and that pointers are variables themselves, I told you that pointers are usually 4 bytes, right? So how can we prove that? The same way we proved it up here. We printed out the size of thing, which is an integer, and we got 4. So let's try doing cout the size of one of these pointers here. It doesn't matter which pointer, all pointers are the same, because of course the data type in front of the pointer has nothing to do with the pointer itself. I mean, it kind of does. All it does is pretty much just tells the pointer, or it tells the compiler, that this pointer points to a memory location that stores the value of that data type. So it has nothing to do with the pointer itself, basically. It just helps the compiler, I guess you could say. I don't know what the compiler is actually doing, but I can just only assume that's what that's for, pretty much. And also for you, obviously, the programmer. But anyway, so we'll do cout, and then now we'll do size of. So we'll do ptr bob inside of here, inline. And then what that should do is print out 4, because pointers, like I said, are 4 bytes. There we go, so we get 4. And let's prove one more theory to prove that pointers are indeed variables. So all variables, like I said, have memory locations of their own. So we can print the memory location of our pointer right here, since it is a variable by itself. So to do that, all we got to do is use ampersand ptr bob, just like we did with regular variables to get the memory addresses of those variables. So now we can run this, and we should get the memory address of ptr bob. And we do. We get 0, 0, f2, fdc8, which is different from where we actually printed ptr bob. When we printed ptr bob up here, we got 00, f2, fdd4. And that's because we are printing the... Oh, it's right here. That's because we are printing the memory location of not ptr bob itself, but the memory location stored at ptr bob, which happens to be the memory location of the bob variable right here. So in this case, we're printing out a different value because we're printing out not the memory location stored at PTR Bob, but the memory location of PTR Bob itself. So yeah, that just proves that pointers are indeed variables, in case you didn't believe me. So yeah, that's pretty much everything I want to show for this episode. Hopefully you enjoyed it. I showed you the basics of how to get a memory address, and then how to store that memory address inside of a pointer, and then how to get that value stored in that memory address, basically going backwards by dereferencing the pointer. And then finally, again, I proved to you that a pointer is indeed a variable itself. And there's a lot more to pointers, which we're going to start exploring next episode and the episodes beyond that, because there's a lot to learn. But these are the basics, and then like I said, we're going to build upon these basics to learn some more things, all right? So hopefully this wasn't too confusing for you. Hopefully this helped your understanding of pointers if you were a little worried about this would be hard or something like that. But yeah, so if you want to see all of the code for today's episode, I'll leave a link for this in the description below, so make sure you check it out. There's going to be lots of comments and stuff, so you can see the explanations over again in text in case you didn't quite pick up on something I explained in the video. And then also I'll have a link to the Discord channel in the description below, so you can join our community and get some friends if you don't have any, or ask for help there, and leave suggestions if you want to, okay? So that's about it. So if you like the video, leave a like if you want to see more, subscribe, and peace.